Hi guys. Well, I'm going to try my best not to scare you away today. And today I'm actually going to talk about not necessarily the use cases for system reflection, because everybody knows that. You could pretty much Google it and pull it up. But today I'm actually going to go a little off topic and talk about ORMs. Because this particular ORM is a special ORM, and it doesn't sound very interesting, because the first version really didn't have any lazy loading. They never really take any change requests, which is not good. And they don't support any deletes or updates at all. And by the way, this is not Entity Framework version 1. And the worst thing is that it only supports one schema, and you can't change anything. You can't even see the tables underneath the schema. So I was told that I was supposed to give a keyboard away, so I'm going to basically give this keyboard away to the person who could actually name what this ORM actually is. Yep. And the reason why, SystemReflection had some pretty good reasons why they didn't want to map to an ORM, but today I'm actually going to do a couple of things. The first thing I'm going to do is I'm going to do deep dive into the CLR metadata, because the backstory behind this is about 3 or 4 years ago, I ran into limitations with working with CISO. I mean, I liked IL rewriting, but I found that there was just certain things missing, and I really wanted to master it. So the best way to master and control something is to learn it. I knew IL, but the problem here is I didn't understand the format that is actually underneath it. And that's what I'll talk about, and I'll try to explain it in very brief terms. And secondly, I'll talk to you about some of the things that you might encounter with System.Reflection that you won't see simply because the abstractions that this particular ORM comes up with are just, it just hides so many things from you. For example, there's certain things like type references versus type definitions that you normally wouldn't see working day to day. Third thing I'm going to talk about is my favorite part. Some of you are wondering, why does he want to do this? It turns out that I had my Doc Brown moment where I just hit my head and I thought about this great flux capacitor moment, and I just said, I need to do that. And that obsession has consumed me for the better part of 2 or 3 years. And some of the stuff that we'll get into is pretty crazy because everybody talks about IL. It's just a common thing that assemblies contain IL. But one of the things that we don't necessarily talk about is the metadata. Because if you look at basic .NET 1.1, you get this kind of dry, bland explanation that assemblies are all about metadata. So I'm going to talk about what exactly is in that metadata. So the first thing I'll do is hop on over and so the first thing I'll do is we'll look into the format of an assembly. And it's pretty interesting if you actually dig into it because, for example, when you have an assembly, when we talk about metadata tables, it turns out that System.Reflection, since it's an abstraction over these metadata tables, you could do things with these tables that you normally won't see. For example, if I open a program, oh, yeah, because all right, I'll describe it. So, yeah, that's a problem. It's always stuck in your head. So is there anything we can do about? Okay. Oh, awesome. Okay, so I have this tool called CFF Explorer, which is an amazing little tool because I can actually look into any given assembly. For example, so if I look at this, this is actually a simple sample library, which is nothing but a Hello World app. Now, the first thing that I mentioned was the fact that in the CLR, you're actually working with metadata tables. For example, in these tables, you've got the module table, you've got the type def, type ref, and if you look at this at first, it doesn't really make much sense because it's just a bunch of tables. But the interesting thing is that all these tables are actually being pointed to by the IL. So for example, if I've got 100 console.WriteLine calls, and you want to do something like change those console.WriteLine calls, in a traditional sense, what you would actually have to do is go to all 100 instances of a console.WriteLine call and change the IL. But the difference here is when you're working with the metadata, all I have to do to change all 100 console.WriteLine instances is change one row. So let's go over some of the rows that we have here. So the module table, there's always one and only one module table in practice. There might be multi-module assemblies. At the same time, there's this is one of the more interesting tables, which is the type ref table. Now, in .NET assemblies, there's a distinction between type refs and type defs. When they say type refs, they're actually talking about type references. Now, the difference between, say, type references and type definitions is that if you look and scan over this table, you could actually see all the types being used by any given assembly. So if just by going down to almost the lowest level, it gives you actually more information than you could get with System.Reflection. And this is built into the CLR. All the stuff that I'm showing you has been consistent since version 1. There's nothing new here. And that's one of the nice things, and one of the reasons why I keep working with the CLR, is the languages might come and go, but this VM will be around for a very long time. Secondly, well, if you want to compare SystemReflection to, say, this particular model, it's a completely different idea because, like, with working with ORMs, what you get is you get the nice abstracted model, but there's so many things missing. So, okay, let's. Now, I can't go without explaining some of the alternatives. Like, for example, I have worked with CISO, and CISO's a great tool if you just want to just work with IL. But there are limitations in that it doesn't really support this kind of metadata manipulation. IKVM reflection is excellent, but the limitation I run into them is because since they pretty much model everything around System.Reflection, they have the same limitations. The only difference between IKVM and SystemReflection is that they actually support the ARM model. So you could actually generate assemblies for ARM. But as I mentioned very briefly, the CLR metadata is all about these 5 things. I talked about the tables. There's also streams. There's metadata tokens, the bodies, and something called metadata signatures. And if you look at this chart, I'm sure everybody's familiar with the one on the lower left corner, which is just working with custom attributes. If you work with CISO, you'll be able to do an inspection of a method body. But the other pieces in this puzzle, you rarely ever even hear about. So I'll talk about each one. So the metadata streams, usually there's about 4 or 5. And the most important one, there's a blob, which contains all the binary data. It's this large, massive chunk that contains everything about an assembly except the strings. For example, talk about signatures. We talk about all the raw data is inside of that blob. Second thing is the strings. So for example, if I do something like the names of the methods, if you actually dive into an assembly and you look at the strings, you'll notice that all your method names are in this particular stream. So if I go back to, let's see. If I go back to CFF, you'll see that the strings essentially contain all the strings that are for method names, types, assemblies, everything. What's interesting about this particular stream is that a lot of obfuscators, what they tend to do is they try to encrypt this stream or give it some really, really weird or mangled names. Because the idea that obfuscators want to do is that if you're reflecting on this stuff, you're not going to be able to understand what the method is doing if it's called X, Y, Z, 1, 2, 3, 4, 5. So this contains everything as far as the strings go. But there's another distinction. If you go over to something called the US stream, which actually stands for the user string stream, which is basically just contains the simple hello world text that you normally see. So it's got this distinction. So these are the Unicode strings. So you'll see that it's got that in there. And those are just for your simple strings that are actually used in the program, and the method names are in the other one. Okay. Now, metadata tokens. Has anybody here actually worked with PE verified to an extent where you get some really nasty metadata errors? Anybody? Okay, well, if you're not familiar with metadata tokens, you can think of metadata tokens as foreign key references in a database. So one of the things that happens in a metadata row is that it'll point back to a metadata table or someplace in the stream, in one of the streams. No, I do not want Team Viewer. Okay. It'll actually point back and to various tables. And it's these relationships themselves that actually describe how an entire assembly is put together. Okay, now I realize a lot of this stuff is, but let's get into a couple of the examples. All right. So what I actually did was, what I'm going to show you is I actually wrote a library that reads all this stuff in. I could actually read metadata. And it's the metadata that is hidden away from System.Reflection, simply because of this is something I worked on for quite a bit. And as a backstory, I really just wanted to see how far I could push this. So I've got quite a few demos here. The first one is just a simple example of the difference with working with, say, custom attributes in metadata. So as I mentioned before with assemblies, or reflection even, when you work with custom attributes, it's pretty common knowledge that if you want to get the custom attribute of anything in System.Reflection, you call anything.getCustomAttributes, and it'll get you all the custom attributes for that particular thing. But one of the hardest things that framework developers actually have to run into is, what if you're into an instance where you've got several thousand types, each with 5 methods, and you have to scan through an entire assembly and see if it actually has that custom type. In this case, what's actually happening is I only have to scan through the rows. I only have to look into this one particular table. Oh, sorry guys. I only have to look into this one particular table This is really, really awkward. Okay, let me just see if I could snap this one out. All right. Okay, so here is the difference with working with a metadata waddle. So the difference in this particular case is that I actually have access to all the heaps, all the streams, and all the rows. So at first, it might not seem like a big thing, but the difference with this particular approach is that with custom attributes, I don't have to scan through 10,000 types. In the actual metadata, if you have 5 custom attributes declared in 5 different locations, you only got 5 custom attribute rows. It's just that simple. And again, at first, it seems like a lot of work just to do custom attributes, but I'm going to step back a little bit, and I'll tell you exactly what I have in mind for this stuff. Let's get past the ones and zeros and get to the point exactly why I got into this. One of the things I found out during all this research that I did was, if you treat an assembly as a database, and you think of it as a database, it opens up quite a few possibilities. One of them is, what if I wanted to clone types? How do you clone a type? If a type is nothing but a database row, why can't I just treat it like a database migration? I want to just be able to take a type and move it from one assembly to another assembly. And I want to do this live. I want to do this while it is running and be able to do that kind of thing. But unfortunately, there's no tools that exist that do that. The other question that you might ask is why? Why would I want to do something like that? Because it turns out that there's quite a few applications for doing something like this, and one of them is testing. See, my Doc Brown moment where I bumped my head and realized that I needed to do this is this idea that I could test anything without even seeing the code. You see, with existing reflection, it allows you to inspect the structure of a program. But one of the things that I found out very quickly is that even though you could see the IL, you can't really change the types unless you have to go through one of the other libraries, and they don't support this kind of stuff. More importantly, one of the things, what's a better way to describe it? So with legacy code, one of the problems that you run into is, what if you run into an instance where you have a 5,000 line method with possibly hundreds and hundreds of side effects, and nobody knows what it does? Of course, you could still use automated refactoring tools, but there's no way to actually test if it does exactly what it's supposed to do even after you refactor it. Even if you have ReSharper, even if you have all those tools. So my idea was, if I could take a type or a method and completely pluck it out and then run a whole bunch of inputs through that in a completely isolated environment and capture all of its side effects, and then have that imprint of all those side effects for that one method as a profile, that basically gives me the behavior of any given method. If I swap this around and I separate that profile of that one method, I basically have an automated legacy test that describes the behavior of one case for that one method. And I don't even need to see your source code. It's all in the metadata. It's all in these rows. And it's these kinds of things that I dream about at night. And it's just, I'm starting to run into limitations with the CLR, not because there's anything wrong with the languages themselves. It's just this stuff that I'm working on applies to any language that you will use. If you can affect it, like right now, I understand a lot of this stuff is like way, way over your head. I mean, it's understandable in the same way that if I were to come to you back in, say, 2003, 2004 and talk about dynamic proxies, you'd kind of just look at me funny until maybe today, and when I talk about, say, something like lazy loading. I mean, nobody really thinks about lazy loading, but that's the kind of thing. This is something that I pretty much set out to do. I mean, there's a few things I want to do in life. First is get married and have kids. Second is I'm going to finish this library. Because it means everything. It's basically the epitome of everything that I've strived to do with working with the CLR, because it's like that story. If you ever played, if you're one of those video game addicts like me, you ever play one of the Jedi games or Star Wars games where they say that in order to be a true Jedi Master, you have to be able to forge your own lightsaber. In this case, in order to really master the CLR, you have to be able to create your own System.Reflection. And this is what I am setting out to do. And I'm going to put this out in public record, so I am totally accountable for it. And in general, what I'm actually working on is something called Tau. Tau is a library that manipulates assemblies. And the thing about System.Reflection that always gets me is that with working with the other libraries, has anybody tried to modify a library that has no tests? I understand that in some cases it's okay not to have tests, but when you are working with something that is so unforgiving that even the wrong byte will actually completely invalidate an entire assembly, there's really no room for error. And what happened with me in this case is that I really had to start from scratch. I had to look into the ECMA 335 spec, which is basically the specification document for all you waterfall guys for the CLR. And it's massive. But one of the interesting things is in the process, I found out all these amazing things. And you can find out on my blog as I went through the process. But pretty much, this is what I've been obsessed with. Codemania is the perfect place to do this because I'm in a room full of geeks, and I don't think I could relate this to my mom, my dad, or they just don't get it. So, other than that, I mean, I'll take any questions. Yeah. What's that?
Sorry, I just want to get it so we get it recorded for the tape when we publish.
And I'm sorry about the code examples because the screen is like.
It's kind of not really a question, but can you give that to the MEF team because MEF is really slow at scanning assemblies? It'd be really awesome.
Well,
looks really cool.
I can give an entire talk on ranting about that. But so the MEF team, it's completely different. IOCs is a completely different domain. So it's just a natural extension. So basically, they just wanted to bake in aspect-oriented programming and program construction, which is a different realm, but it's still related. So the answer to your question is, I don't know. I mean, if the MEF dealer wants to do it, it's certainly up to him. In my case, I pretty much put down IOCs because I got to a point where I think I did enough, and we're in the space nowadays that IOCs themselves are pretty mature. Nobody really questions them anymore. So the space that I'm getting into is not just System.Reflection where you're just scanning assemblies, but I actually want to move into the next stage where programmers are not only aware of themselves, but they could actually change themselves. And ultimately, this stuff goes all the way back to a use case. I want to be able to help people, but I want to do it in such a way that it affects everybody and it benefits everybody. Any other questions?
Philip, what's the status of Tau at the moment, and could you give us a little bit of a walkthrough of how it might actually fit some of your use cases? Can you show us some of the APIs that you're thinking of and some of the ways they can be applied?
Okay, so right now Tau is still low level. So one of the things I did with Tau is that there's two sides to Tau. There's the read and there's the write. So if I intentionally avoided generating an object model or doing the ORM approach from System.Reflection simply because I didn't want to put any abstractions because I didn't have the use cases to use an object model yet. So what I did is I finished the read side. So all these things that I've talked about is already done. You can actually scan an assembly. You could see what's in there and look at it raw. But as far as the use cases are concerned, this stuff I would say is more for, I don't know what's the better term, it's called framework porn, because I have to be honest in saying that your average business user is not going to directly use this stuff. When I talk about this is really for the guys who are going to create some amazing things through, for example, AutoMapper, like they used my proxy for a while. These are things that will help people be able to do some pretty crazy stuff with this. The right side is painful, so I'm still working on that.
Let me give you an example of something where I would quite like to use something like this. I've got a problem with dealing with versioned assemblies. So I've got an SDK that I need to be able to host in my product. I've got to be able to make calls into that SDK, but I also need to be able to deal with different versions of that SDK. So when you talk about, say, being able to move types from one assembly to another, or maybe being able to switch around on versions or proxy versions in a way that allows me to write a consistent adapter layer so that my framework can talk to a consistent interface, and that can be dispatched off to different SDK versions.
Yeah.
Is that something that Tau could help with? Can it help me with things like the strong naming problem that bedevils me?
That's one of the planned cases. It's a good thing you brought it up, because one of the hard things that everybody runs into on the .NET framework is this idea of versioning. So, I mean, on deployment day, you think everything's okay, and all of a sudden you find out that there's a versioning error. And the ultimate reason why you get these versioning errors is simply because the CLR is doing dynamic binding. There's no such thing as static binding in the CLR unless it's within the same assembly. So what you have to do, the idea behind Tau is I want to be able to control these rows so that I could pull in the rows into an assembly at runtime, have all the same IL, and be able to version it. Because if this is just nothing but a database migration, then I should be able to version it just like a bunch of rows. Just pull it in. If I need to make a method call, you could either intercept the interface and redirect it to an implementation, which is pretty standard nowadays. And at the same time, it really gets rid of the headaches, because if you say, I want version 1.1, I don't have to do something crazy like fall back to the GAC, which always fails me. And it's never worked. I mean, I knew the intention behind the GAC, but it's just never really panned out too well. Anybody else? Actually, before I go on, who was the one who answered the question? All right, it's yours. So any other questions? Because
we have one down here.
Just yesterday, I was having to use System.Reflection to make a sort of a unique key for a business model,
okay.
just so that we could find out whether it had changed, and therefore whether the cache we could pull it out of nice and quickly was valid. And so, I had to find out all the types it used and its members, and the ones that those referred to, and so on. And every bit of information I want, it was a call to some System.Reflection method, which may or may not be lazy loading, and it was always hard to know how much of it was going to be performance issues and all that kind of stuff. So if I'm understanding correctly, if I was using this, I would have sort of a preloaded almost set of database tables, so just using a little bit of memory sitting there, and I'd just be able to sort of access it relationally, and I'd be able to find out, get a sort of a signature or the details about the class I'm looking at very quickly. And
yeah,
right. So
it basically the difference between working with System.Reflection is, because it's an ORM, it tries to abstract quite a few things away. So it would construct, for example, if you got the example I gave earlier would be the constructor, but if you wanted to scan it directly, using this tool, you could see it. So if there's really five custom attributes declared, there's only 5 rows. That's, if you compare that versus an entire type scan with an assembly with 5,000 types, there's a huge difference there. The other thing that he brought up was this idea of references. There are tools like TypeMock, NCover, and other things that rely on Cecil to actually scan and figure out what the dependencies of an assembly are. In this case, within two seconds, you could easily be able to just go through all the type ref rows and see, this is using this type. That's it. There's no, it's very clear cut in that sense. But there are, and I'm not gonna lie, there are trade-offs to this, because the abstractions that System.Reflection actually provides you are very valuable abstractions. It's just, if you learn what's underneath this, it could save you quite a bit of time. I mean, it's really the difference between driving automatic and driving stick. If you could live your life driving automatic, and you probably wouldn't know the difference, but the fun is when you start to learn how to drive stick. So, any other questions?
So you've kind of stepped away from doing the ORM approach so far with what you've written here, but you've also identified some use cases that System.Reflection is not really good at, but people could want to use in a more abstracted way. So for instance, one of the ones you mentioned was pulling all of the somethings that have a custom attribute from an assembly. It can be quite slow, I think it was Ryan was saying, quite slow to scan a whole assembly. Now, you did point out it was a lot of code. Have you got any plans to do that kind of ORM thing? Are you working with anyone who said they are interested, or is that something that would be open for other people to build upon your stuff with?
Well, I really hate to give this line because it seems kind of cheeky, but yes, I accept pull requests. But ideally, I'd want to do it myself because I'm not going to put this on anybody else. This is something I've dreamed about doing. This is what I love to do. So ultimately, yes, I will create an object model on top of that. But one of the things I came up with writing Tau from the very start, and you'll see in my blog post, because I'm going to just talk about everything to a really sick detail, is with Tau, I want to be able to read what I write and write what I read. So it has to be consistent all the way through. And I finished the read part, but the toughest part is being able to write it back. Because if you look at my source code on GitHub, you will see some pretty interesting cases where I actually pluck out sections of an assembly, read it in, and then do a write and then hash, and just do a hash by hash comparison of what I wrote. And the idea there is I want to be able to do that kind of comparison, but I also want to be consistent. Because this is something that I would write for myself, and I'm not gonna, if I want to get this, I don't care how long it takes because I really want to get it right. So to answer your question in a very long-winded sense, yes, there will be an object model, but more importantly, I want to make sure that I get the writes done before I start building anything on top of it. Because you can't really do metadata manipulation unless you have the whole picture, which is both writes and reads. And the reason why I actually called it Tau is because it's two-sided. You can't really do assembly manipulation without reads and writes, or one or the other, which is the problem that I had with System.Reflection. In some cases, you could read, but you can't write. For example, I think there was a method called getIL as byte array, which gives you the IL as an unusable byte array, but what am I going to do with that? If I go back to, let's see, I'll give you a quick demo. I know I'm going to be running over time, but I just have to show this. All right. So here's the method body demo. And just to show you what I have so far, you don't need to understand all this code, but the important part is I've gotten to a point where I could actually read the instructions, like all the IL. So for example, if I do a simple run, and this is just a console WriteLineLab, so there's nothing special about this if you just looked at it in Reflector. If I go to the instructions here, what does that look like? Basically, I broke it down into just a simple array of IL. The difference between this and, say, Cecil is the fact that when I do a call instruction, it actually tells me what row it's pointing back to. So think about this. This gives you enough information that if you scan through the IL, you could actually see what these table references are. This is pretty clear cut. I could actually go through this in CFF Explorer and say it's in member ref row 17. Now if I hop over to CFF itself and I just try to find the mouse pointer, I go over to the member ref table, and what do you know? I have row 17, console.writeLine. So what I'm actually doing here is giving you the same fidelity as ILDASM. I'm giving you ILDASM as an executable program. But not only am I giving you ILDASM as an executable program, I'm actually writing IL assembler into a way you can manipulate as an object model. This is what keeps me up at night. So before I go, any last questions?
Just one last question. We'll just do it really quickly and then we'll break for lunch. You're keeping people from eating their lunch, right?
Yeah, I apologize.
All right, sorry guys. But you mentioned before about you're changing the metadata and changing the IL and what have you. How does that conflict with, say, for example, you talked about doing it at runtime?
Yep.
So presumably at runtime, some of that code's been evaluated, it's been JIT compiled, it's got raw memory pointers in there. How do you deal with that kind of thing?
So a typical workaround for that is you can't, okay, supposedly you cannot change, in the traditional sense, you can't change code once it's been loaded into memory. But what you can do is, using this tool, I could generate a proxy assembly. So I would actually replace the real assembly with either a bunch of stubs, or I could clone the type and just change it so that it redirects to an interface. So if it redirects to an interface, I could just swap out the actual implementation at runtime. And that's basically all you have to do. So in a signed scenario, which is another reason why I wanted to do this, if I have a signed assembly, let's say I wanted to change the BCL, and for God knows why I wanted to improve link to SQL and add support for, say, Oracle. Normally, you wouldn't be able to do anything if they mark a class as sealed, but there's nothing stopping me from cloning the class that implements, you just follow the interface all the way up, and then you find the one that is dependent on everything, and just implement it without either the sealed marker, or you just generate a new one. The best part is, with this level of control, this really is the holy grail of metadata of manipulation on the CLR. And it's why it's huge, because you can really do anything. And that is exactly what I'm after. So thank you for coming.
Thank you very much.